All right, today's session, brackets, semicolons, and compiler errors. So we want to just get up to speed on what the heck happens when we compile a C++ file. So right now the file is called brackets semicolons.cpp, and I want to actually compile it. So c9.io has a really nice feature where you can just click on the run command, and it knows because it's a CPP file that it is actually a C file. But when it runs through and checks for are there libraries to link in, but we don't have any pound include, so there's no libraries. And we go through each of these things, and it says debug, relocation, invalid symbols. These are all things the compiler needs. And more importantly, there's a thing called user bin LD. And that actually LD is a linker, and it's trying to bring the libraries together and pull those in to assemble our program. As we go further down, we'll see there's an undefined reference to main. So what's interesting here is that when we have no code at all, the thing that is important to us is that the compiler is saying, hey, there's no main. Now, a main isn't required for a valid C++ file, but a main is needed when nothing else is there. So that's a very interesting result. So let's take a typical hello world program. So I'm going to do pound include, and then we want iostream for C++. And from there, I'm going to make a shortcut called using namespace. And this allows us to, instead of have standard : every function, we're just going to use this to hide that standard piece away, and we're going to work inside of the standard namespace. So, okay, I've got that. And then let's say I just compile it. Let's find out. I'm just hit run here. And what else do we get? Okay, so we have the same exact thing and undefined reference to main. So we don't have a main yet, so we get that particular message. So now let's give it a main. So if I put int, oops, let me click in. If I type int main, now that means I have a thing called an integer return from main, and I can put some parentheses, which are no commands, no operator that we're going to shove into main. So now, basically, I have a default main. I have int main, open curly brace, close curly brace. So that is the main function. So let's find out, do we get something that's valid at that point? And it says running exit code 0. And exit code 0 is success. It actually ran this program, but we really didn't tell it anything to do. So that's where we want to do stuff like give it a little C out. So console out, and we need to put the arrow keys pointing to the console out so that, say, our hello world actually gets there. And if we want a shortcut, end L, it means end line, and it's like a universal way of saying just put a carriage return or enter after that line. So now I'll save that, and I'm going to go run it. So once I run it, it says hello world, and it says process exited with code 0. So now we actually have valid code. But, what I've been seeing is there's been a lot of people with problems about closed brackets, empty brackets, things like that. So let's find out, what does the actual compiler do when things aren't quite right. So let's go to include, and let's leave out the include piece. So you hit run here, and it says, hey, error, include does not name a type, include iostream. So, it doesn't tell you that the pound sign is missing, but it does tell you that something's wrong with include. And it also, if we look really closely, it says line 1 : 1, which means line 1 character 1. So immediately first thing there's an error. But whenever there's an error, it's sort of a cascade. The compiler still tries to make things work, but maybe there's an error elsewhere. So in our case, because that particular library iostream failed to load, it creates a thing about cout. It doesn't actually know what cout is. So it throws an error, and it doesn't know what endl is. All those things that are from our library are no longer available. So if I put pound back, hey, there we go, we're going to be in good shape again, because it knows what everything is. Now let's say I'm going to use a comment. A comment is like a double slash, so that's a single line comment. And I'm going to say, let's take that namespace out. And we hit save, and I hit run. And now it goes, okay, well, we're first error is in line 7, 5. So 7, 1, 2, 3, 4, 5, and it says C out. And I was like, oh. But we know C out's a valid thing, but because I removed the namespace for it, that's where the trouble is. So it's hard to know what's going on because it's actually a missing piece. So if I wanted to fix this and do it technically, like we did include the library. So when we include the library, we can do it with doing std : and then save that and run. So what we're doing by using namespaces is trying to help ourselves not have to type so much stuff. But what happens is when you have many, many, many libraries included, that namespace, it becomes important. Where did my function come from? So that's another area of investigation we'll take a look at. Now, let's say we'll leave that commented out. I'll show you the other type of comment. If I use /* and a */ that actually ends the block area. So I can comment out block areas. So I'm no longer using that. And I'm going to actually take out that include, and all I'm going to do is have a main. So now that all I have is a main, I'm going to click run, which actually runs the compiler, and there's no errors. So typically here, what's the smallest program we can make that does nothing? Is int main, parentheses, semicolon, or the curly bracket, and the curly bracket. So this is actually valid. So one of the things about experimentation is that you can experiment around and try to find the smallest valid thing you can do. So one of the things that's important for us is that, say we want to use some variables, we can say variable integer, so int a, and I can tell it you're going to equal 2, and then that's also, so now I'm following the proper syntax. So okay, so great, I have AA and it equals 2, and I can hit run here, and let's find out. Oh, okay, works no problem. So now if I say I want AA to equal AA plus 2, save that as well, do run, and we have it runs through and there's no error. So what it is mathematical expressions, if, thens, and else. So we're doing everything but using the console, and all of those particular types of code work. So that's actually another thing, is when you're working with variables, working with control flow, all of that works. It's just when you start using features that are not available. So we're going to just go back and we'll put this in. I'm going to simplify it for us so we don't have to type so much. And let's see, we'll get rid of this piece. And then I want to use the namespace. So that's our shortcut. We want to use using. And let's say save. So, all right. So now okay, well, let's find out what cout was. So we're going to do console out AA. And we'll indel that. All right. So now we have our code. I've saved it. Going to hit run. And blammo, whoa! Okay, so the other part is the compiler is looking for semicolons to end the line. And in this case, I have a line that has problems. Like in my brain, I just know, okay, I see right away. But the compiler is what actually tells us exactly what's happening. So if I go over here, line 12, character 23, it expected a semicolon before the full colon. And that's cout, and it gives an example of where the line is. So it actually shows us in this case where exactly the problem is. So I can just go and say, okay, all right, well, I want line 12. I see that. Oh, hey, let's get that in there. So that's what the compiler's going to do. It's going to run through everything from top to bottom in order, and it's going to look for those semicolons. Now, what I don't recommend is doing the following, but this is totally valid. So semicolons end the line, but you can actually have all the lines on one. So if I run this way, you'll see it actually does hello world and gives me 4. So it's valid to end each expression with a semicolon, no problem. But you typically want to see what's happening, so you'll put them on separate lines so you can read them top to bottom. The compiler doesn't really care about how you read, it just cares that you can see stuff. So let's say typical is a semicolon can be missing, so that's one condition. Another one is where, say, our open and close brackets. So I'm going to take the close bracket and I'm going to compile without it, and it's going to say, hey, error expected, a curly brace. There was no curly brace. It tells us what it knows last is that there was a semicolon over here at the end of input, but we're expecting a curly brace at the end of the input, and that would be here. Now, the problem then is it's sort of like, again, it's missing, so you got to choose. You could put it immediately here, and that would work, but it doesn't help you read your code. So style actually matters too. So we want our code read, so I'm going to just move it to the line down. And let's see, line down, save that, and we're back in action. Runs, does all the stuff we want. Next, I want to look at the other part. Let's say the forward curly brace is missing. I'll delete that out, and I'm going to hit our run, and now it's going to blow up again, but this time it says expected initializer before cout. So the initializer was supposed to be part of this function business. So what happened is the compiler looks at what happens in a new way. It suddenly thinks, because there's no semicolon there, it thinks the line looks like this, straight into cout, and so it thinks it's using stuff before it can actually use it. Now, beforehand, it also goes and says, hey, this doesn't name a type, because what happens is this whole thing, this whole chunk is now invalid. And it says, hey, well, we expected some sort of declaration before the curly brace, so our forward curly brace is missing. But let's see, what can we do to solve this? I can just literally put it there, and this will generate us valid code, less human readable, but valid code. So that's what it's doing. Helps you out with that. Okay, so then what's the other scenario? Okay, so one of the other common things is the console nomenclature is that we're trying to push everything to the console, so we have these left arrow type shapes. If I reverse these and point them backwards, it's going to give me trouble too. So bang, this actually is really like, hey, whoa, lots of stuff going on here. So now I've got cout pointing to hello world, and it's like, hey, these really aren't valid functions, and now it's going through here and saying a whole bunch of things could be valid for you to use, but you're not using any of them. So now we've broken this big rule. It gives you lots of text. It does tell you what line this stuff is happening on. So we have line 8, character 10. There was a problem there. It says it was an operator, and that's not working out so good. So now we'd come back and we'd flip that over that way. Now, this is the other part. cin is our other common function, and we actually want to put, say, data into that variable. So this will ask us for that particular information too. So I'm just going to run through that one, and it's going to wait there. It's not going to ask for anything, but because we told it to, we can still say, I want 22 added in, and boom, 22, hello world 24 gives us what we want. Now, here's the deal. Same problem. If I throw these things backwards, I'm trying to push, instead of information into the variable given that arrow structure, I'm trying to push it into the console in so it shows it out. So it's like putting the out in the in, and it totally gets confused. So anyway, let me hit run here. Boom. All right, so now I'm looking at it, and it does tell me, hey, that's a no match for that kind of operator. Just not there, not defined. Maybe you could make it, maybe you could define it, but boy, that's a problem. So now I'll just take this, empty that out, run that, hit save. And that gives us a majority set of errors. I'm just going to run. I'll say, well, let's get rid of equals, AA. Whoa, so cool. So in assignment, it knows that assignments need to happen, but there was some sort of parser error before that semicolon that we had, and it tells us where it is. We can just push that in. So I would say this is the fast introduction to the curly braces, the compiler errors, the semicolons, and the only other thing we didn't play with were parentheses. So if we have a parenthesis here, I can just hit run, boom. It'll say, oh, I expected this, but on the second line, 814, I expected a close parenthesis for the open parenthesis. So if I go back, I can put that in, and we're in pretty good shape with that. We'll go back, delete that out, do that run. And now, boom, it's saying, okay, well, you can't have the close before the open. You got to balance it. And I'll say, okay, what is that, line 710? All right, great. Go here. And now it added, so sometimes your program adds your extra stuff. So it added me a close because it expected it. Now I'll remove that extra bit, hit save, and now we're running. Oh, right, it wants the input, so if I put in like a 12, we're in pretty good shape. Boom, and let's see, oh, right, and there's one other thing. We're gonna do a separate video on this. If I run this again, we're gonna do, if I did like ABC, those are like not numbers, but let's see what happens. It gives ASDF and it gives us a 2. So this is a runtime error. It gives us an unexpected behavior, and we're gonna pick up to the mystery as to why, say, AA equals AA plus 2, but AA was ASDF. So anyway, that's a really good puzzle to solve while we are working on that. So my question to you is, why could I give integers as characters? Thanks.